Hello and welcome to Advent of Code Day 6. My name is Harry Moreno. You're watching Domain Expert. Let's begin. The device on your wrist beeps several times, and once again you feel like you're falling. Situation critical, the device announces. Destination indeterminate. Chronal interference detected. Please specify new target coordinates. The device then produces a list of coordinates, your puzzle input. Are they places it thinks are safe or dangerous? It recommends you check manual page 729. The elves did not give you a manual. If they're dangerous, maybe you can minimize the danger by finding the coordinates that give the largest distance from the other points. Using only the Manhattan distance, determine the area around each coordinate by counting the number of integer xy locations that are closest to that coordinate and aren't tied in distance to any other coordinate. Your goal is to find the size of the largest area that isn't infinite. For example, consider the following list of coordinates: 1, 1, 1, 6, 8, 3, 3, 4, 5, 5, 8, 9. If we name these coordinates A through F, we can draw them on a grid. Putting 0, 0 at the top left, you get this. This view is partial. The actual grid extends infinitely in all directions. Using the Manhattan distance, each location's closest coordinate can be determined, shown here in lowercase. So this is a portion of the infinite grid that has the points labeled with the closest point in the input assigned to every cell. Locations shown as dot are equally far from two or more coordinates, and so they don't count as being closest to any. In this example, the areas of coordinates A, B, C, and F are infinite. While not shown here, their areas extend forever outside the visible grid. However, the areas of coordinates D and E are finite. D is closest to 9 locations, and E is closest to 17, both including the coordinates location itself. Therefore, in this example, the size of the largest area is 17. What is the size of the largest area that isn't infinite? To begin, get your puzzle input. And I already looked at it. So we can begin. So we can begin. Day 6. Touch input txt. Actually, been doing this cute way. Right? Yeah. That's the cute way, just piping it directly from the clipboard on OS X anyway. Your mileage may vary. If you're on Linux, there's like another way to do it. Okay, so we got the input. I actually didn't. I want to actually put the REPL in here. Python 3 REPL and Python 3 solution.py. Solution.py. Right. Okay, empty. Oops. Let's see, so if we were to read in the file and forget how I do it, how I've done it. I just did open, read, strip. So, right. Is input a keyword in Python? A built-in function? If the prompt argument is present, it is written to standard output without a trailing new line. The function then reads a line from input, converts it to a string, stripping a trailing new line, and returns that when any file is read, blah. So probably don't want to call my variable input. Maybe that's why I called it point or polymer in the last episode. Input.txt, read. I think the strip goes and removes any trailing new line there might be. Okay, and then as a sanity check, is okay. And then, so we basically have several XY pairs. The Manhattan distance is conveniently, I mentioned this in an earlier episode, but there's been this document floating around since 2016 by Peter Norvig, and they shared some functions they like to use during competitive programming. One of them is the city block distance, so I'm going to go ahead and use this. I'm going to go ahead and use this. This is essentially the Manhattan distance. It's another city block distance, ends up is synonymous with Manhattan distance. And I already am familiar with it. I sort of read it. It basically it can take 2 points. If you just provide it with 1 point, one tuple, it'll use the origin, a second point 0, 0 as the other point. But then basically you get the absolute value of the x component of the first point minus the x component of the second point plus the absolute value of the y component of the first point minus the y component of the second point. And this is actually using another helper function defined right here, which basically just pulls out the first component of a tuple. And y would pull out the second component of a tuple. So if we stick to these conventions, no paste, we're done pasting. We have city block distance. If we were to, let's say, this is test it out because I've never used it. If I wanted to do just really quick, calculate the distance between 1, 1 and 3, 3, I would expect some positive integer, line 13. some positive integer 4. So that's a pretty good head start. I don't have to think about the Manhattan distance. We can just treat it as a primitive dysfunction. As a fairly common thing in programming puzzles. So right, so that's Manhattan distance. And then we would want to sort of take the input and put that maybe into a list of tuples. So for, I think, for a thing in points, I'm not sure exactly what it'll pick up. Print I, because it could pick up the lines or it could pick up the characters. So I'm curious as to what so those are characters. So those are characters. I would want to maybe points open. I want to further pre-process this points variable and maybe I need to sneeze, sorry. Excuse me. Yeah, let's see if we could maybe split on new lines. All right, so we're splitting on new lines, and then so that is essentially, that's pretty close to splitting by point. So then we could probably process this by line in points. I really want to I really wanted to call this input, but that's a reserved, that's a keyword, that's a reserved word in Python. Maybe file input. Try that. So that's file input, and now I would really like to make a list of points where we have a list of tuples, and we can construct this, we can accumulate this, build this by accumulation. I also updated my preferences to use 2-space indentation, which I prefer for this series. I wanted to sort of make better use of the horizontal real estate, but when I write professional sort of software, not these programmatic puzzles, I stick to 4-space indentation. But yeah, so that's a change I made. 4 line in file input. Basically, so we have a line. I would like to sort of append. New append. Okay, so yeah, you can append. And I didn't look it up in the docs because last time I did that, it wouldn't show up. It was like array append. And I'm not really sure exactly when does a Python list get considered an array. This module defines an object type which can compactly represent an array of basic values, characters, integers, floating point numbers. Arrays are sequence types and behave very much like lists, except that the type of object stored in them is constrained. The type is specified at object creation time by using a type code, which is a single character. Following type codes are defined: characters, shorts, ints, longs, floats, doubles. Okay. In any case, it looks like I can use that. I would like to append line after I do something to line. So there's line dot split, and you could split by that, and you would get, if we had a string like this, let's split by this, a comma and a space, you'll get the two coordinates. And I would really like to cast that to a tuple. Could you just pass it into a constructor? This. Cool. Didn't know you could do that. So we could actually write this fairly compactly. Tuple. Blah. Interesting. A little cursor than I'd like, but I get it. If I wanted something more readable, I'd probably say something like point is equal to, and yeah, we should probably go with that. And then points out pen point. Yeah, I like that better. It's more readable, more understandable. And then at this point, we should now have a list of tuples. We've properly processed the input. Cool. Now I have the input in a format that I like. And so I went ahead and wrote some pseudocode before I started the video, and I already have a sort of like a plan for how I want to solve this. Basically, so for each point in this finite rendition of the infinite field, we're going to want to calculate, basically loop over every point in the input here and label every point with the closest point. Label every cell with the closest point from the input by, you know, like naively calculating the Manhattan distance for every point and determining the minimum. And in that way, we sort of carve out these regions for every point. So let's go ahead and do that first. There are the points, and then there's probably going to be some sort of grid. Could model it this way. Grid, which is a two-dimensional list. In Python, they're lists. And then for x in range. So we're also going to probably rely on two inputs. This test input as a sanity check. Actually, yeah, we want to do PV paste. Okay. And so, you know, I'm sure there's a more efficient way to do it, but I'm not there yet. So I'm going to just make a two-dimensional, a list of lists, and maybe sometime soon I'll figure out how to do this more efficiently. But basically, I want to also sort of figure out the bounding boxes. From just like a visual inspection of this, there doesn't seem to be any negative numbers, so I think one assumption we can make, I don't see any sort of minus in here. I think one assumption we can make for this problem is that the grid is bounded at 0 on the top and on the left at 0. And then we can determine the right and lower bounds by finding the maximum x and y values in the input, and those would correspond to the right and bottom bounds of the grid. So I wanted to sort of figure that out. I want to for line in file input, figure out, you know, extract the point. While we do this, we might as well figure out max x equal to 0, max y is equal to 0. We might as well compute this, and I think this is fairly efficient if we figure it out here. So point x and into point, but before breaking, if x, so we're using this function from Norvig, if x of point is greater than the current max x, I want you to go ahead and update max x. And I think that is not too inefficient. If y of point is greater than max y, max y is equal to y of point. And so then we can sort of figure out the bounds. And so for x, I'll probably call this C for cell. For cell in range max x, my tabs aren't as nice. I want the tabbing to work as two spaces as well. Need to figure that out. For C in range max x, line well, max Y, right? So first we're going in from top to bottom. Try to do that as Y. For Y in range Y. For X in range XX. In the list, an empty list, and then for X in range blah. Grid. Y. Not append. Dot. And I would like to, as a sanity check, print out the grid. Type error greater than is not supported between instances of stir and int. Oh, line split. Can I do a map on this? I'm really rusty on this. I think you can do a map like that, basically. It would be like a cast. Object is not iterable. I'm curious, how to use map in Python? Map function iterable. Map function iterable. Map string function. Okay, interesting. Never done that before. So first you put in the function that you want to apply. Okay. Did I have the... Did I do pretty print? I've become partial to this pprint, pretty print thing. That's a built-in into Python. Pretty print, import pretty print, blah, printer. Pretty printer and then pretty print stuff. Let's see how that works. Okay, so that's our grid. That's our sanity check grid. The other grid will be much bigger. In the future, it would be cool to maybe pretty print this in a more dense way. because this grid stuff, this is very common to Append a code. We've already seen this twice. This is the second time we're seeing this. A grid of dots. But that's for later. That's some other time we'll do that. So that's the initial state of the grid. We would like to now loop over the grid. Right. We could probably instead of just initializing this grid, we probably could compute the entire all of the labels right in this loop. It would be more efficient. So instead of putting append dot here, we could put in the logic to actually compute the labels. So let's see, let's try that. So we're looping y, we're looping x, and so this is, we're going right here on line 28. We are actually going for every cell, and then in our pseudocode we stated that for every cell we want to calculate the distance to all input labels, to all the points, determine the minimum distance, and then that is the label for this point. So we can have a helper function which is find label for the point, where the point is a tuple x, y. This will be the label, and we could just put that there. We could, this is a helper function, so I'm actually not sure. I don't think you can do this in Python, which is use a function before you define it. So, but just to double check, find label, we'll take an argument, return dot. Actually, yeah, this is executing from top. Yeah, so you can't do that. We want to have it as a helper function. Let's see if I type error. It's surprising because I thought that Python was more permissive than that. Let's see, point, but we don't use it. Okay, and then so find label will will compute distance to every input. Yeah, input returns closest input. So point and points, and we're sort of depending on, we're going to have to depend on the points having been computed beforehand. So then now for point and points, closest point is equal to blah. And then return closest point. And then for point endpoints, we have P. We really want the city walk distance between P and the point. And we say that distance is that. Now, if distance is less than this point is blah, and in this is 0. Well, infinity. We do infinity. Inf math.inf. Import math. Min distance starts off as math.inf. If distance is less than min distance per min dist is equal to this dist, and also the closest point is equal to this point. And that's something that I didn't notice till just now. We don't really have letters for these inputs. So the label will have to be the actual just coordinates, because I don't think it makes sense to start assigning them names. You can just say that it's the 0.55 or whatever. And so find label, closest point is that, and then point, and then find label, append. That's interesting. So that's gonna mess up our little cute little grid, because it's just going to be a two-dimensional list of tuples. But if we were to print the grid now, there's a p print. Right. Not as cool. But does it make sense? Does it roughly make sense? This is presumably the same as this thing, except we didn't account for the ties. 1 1 3 4 3 4 3 4 1 2 3 4 5 6 7 8 9. I think that's correct. 9. And then the other one had 17. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. Yeah, that's right. Except for the ties, which we should probably figure out. So it's if x, what is this doing? All right, it's the label logic, right? Find label, closest point, blah. Min distance is blah, 4 point endpoints. if distance is less than min distance. So for point and points, find the minimum distance. We might naively iterate again and basically ask for all the points. Is there more than one point that has the same distance? So I'm gonna go ahead and do that because I can't think of a better way. Because we need to find the minimum. And then once we find the minimum, are there two of these? Is that minimum shared? Unless we keep a track. Unless we keep track of it, right? If distance is less than min distance, its closest point could be a string. If distance is less than min distance, update it. If distance is equal to min distance is the same, but closest point needs to be updated. Be a list. A list if we care, but we don't care. We just want to make it a dot. Conditional. Or is that right? 1, 2. Right. 1, 2. And then 1, 2 up here. And there should be 2 over here, right? One, two, three. What coordinate is this? 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 8, 6. 8, 6. Wrong. 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7. Outside of the region. Why is that outside the region? Because I did not interpret the C correctly. A, B, C. 8, 3. 0, 1, 2, 3, 4, 5, 6, 7. 8. There's some off by 1 error. So we should be having some zeros up here. For y in range max y. Where, whoops. Where max y is y9. At y 0 to 8. Excuse me, I need to sneeze. Or not. Maybe this is 0, 0. And this is the actual point. This feels correct. Like, I understand that the bottom one... Wait, no, I don't. I don't understand that. This F. A, B, C, D, E, F, 8, 9. Nothing wrong with that. 8 and 9. The C, A, B, C, 8, 3. 0, 1, 2, 3, 4, 7. Maybe it should go to range plus 1. In both dimensions. One, two, three, four. Wait, 1, 2, 3, 4. There's a 1. Presumably this is 0.89. Error 2. Yeah. And in the example they went ahead, they went one further in the x direction, which none of these points actually reached. But on the bottom part they did flip off the grid at a point. I knew that from just reading this carefully. This grid that they demonstrate here is one more in the x direction than it had to be. So that's correct. That's good. And so we've labeled, okay, that was the first part of the pseudocode. Loop over every cell in the grid and label it correctly. And then to determine now the infinite areas, the way to do that is to basically go over the entire perimeter and accumulate all the labels. And those are the infinite ones. So then basically you subtract those points from all the points. And what you're left with, that remainder, that difference, are the finite regions. Let's try that. let's basically accumulate infinite points, basically for I in range. Actually, we might be able to do that in this loop. If I had a different data structure, I'd probably do it in a different way, but since it's less, we might as well accumulate this while we're constructing the grid. So we can determine the infinite points. They're basically all the labels on the perimeter of this thing. So for y in range blah, for x in range blah, do what you're doing in the grid. That's fine. But then if y and we should be mindful that's it's the grid of the points, not the grid here per se. So that would be min x, min y. Calculate it here. Since we're calculating the max, we can calculate the mins here too. So if x of point is less than, right, minimum, right? So if x that is less than the current least xy, min x is equal to x of point. And if y of that point less than min y is equal to y of that point. So this is the top and the left bounds of the grid. And basically we want to get all those labels. Which might be simpler to do this way. So basically for y in range max y, it's not that, it's the range of max y minus min y, or y x in range max x minus min x. And I have to be careful about off by one errors. But let's just see if it works for the small case and then figure it out for the big case. So infinite points want to be like whatever, basically inf points, append, whatever label is in there. I guess discard any dots. Whatever's in grid or x, y, x. Yeah, we're indexing by y first. Just the way it works well for generating this thing. And I would really love to look at that. See what that looks like. It'd be great if this is a set too. What do you do for sets? Add. Yeah, add. Is it dot add? Yeah. Okay, so we got 8355163411. Does that make sense? Basically 1, 2, 3, 4, 5. 1, 2, 3, 4. Two. Which one's wrong? 1, 1. Well, D and E, right? So A, B, C, A, B, C. 3, 4, and 5, 5. 3, 4 shouldn't be here. Why is 3, 4 here? Three, 4 should not be here. Label is equal to label is not that. Then go ahead and do that. Zero given. Okay, so we went ahead and omitted the dot. But why is 3, 4 here? could you print x is x and y as y? 0, 1, 2, 3. Oh, so I got the delta correctly, but I didn't incorporate that into the thing. Start, stop. You don't even have to subtract, really. If you have this like this, that would work. One, two, three, four, five. This 3, 4 is still here. It's not good. Seven, 8. Maybe subtract 1. I find it really funny that I'm able to do this without any change. Okay, yeah. I'm not sure. Let's see. Or y in range. Min y, max y. Max y. Oh, not inclusive. So the grid we constructed is based on goes all the way to the origin. But the grid that we are interested in terms of determining infinite regions is not based off of the origin. It doesn't go to the origin necessarily. And so we need to be traversing a different sort of border. And so in the example, we go all the way up to 8, 9. 8 on the x-axis, 9 on the y-axis. We are interested in the box bounded by the points 1, 1 in the upper left and 8, 9 in the lower right. We're also interested in one, 9 in the lower left, 8, 9 in the lower right, and 8, 1 in the upper right. And so max x is equal to 8, max y is equal to 9, min x 1, min y is equal to 1. And we want to reverse 1, 1 through 1, 9, 1, 9 through 8, 9, 8, 9 through 8, 1, and 1, 1 through 8, 1. And I just generate that set. See, that's all wrong. 7, 3? Why would you be going to 7? It's presumably the x. X. That's not right. Min y, max y. Min y is 1. Max y is 9. Oh. Yeah, I'm not supposed to loop over it like that. There's really only 2 points when you're going in the y-axis. For y in range blah, well, actually for x in range blah, but if x is min x, go ahead and do this stuff. Else if x equals max, or x equals max, max. Wait, no. We're going over it in the y direction, right? And if let me go in the x direction. If y equals min y or y max y, use every x. Else use max min x. or y in range min y to max y plus 1, or x in range min x to max x plus 1. If y equals min y, or y equals max y, use every x, which means min y min x min y min x max x through max x, right? Or y in range min y to max y, or x in range min x to max x. If y is the minimum y, use every x. Otherwise, just use the minimum x and the maximum x. That's more like it. Let's do 1 and 8. Yeah, 1, 8, 1, 8, 1, 8, and then 1 through 9. Or the values, the y values between 1 and 9. Let's figure out a count. And presumably this bounding box is it should be 9 high inclusive, 1 through 9, and 1 through 8. So 9 plus 9, 8 plus 8, 16, 18. Can do this. 9 plus 9 plus 8 plus 8, 34. So here's the sanity check. This count should be 8, 34. Count plus equal 1. Do that here. I want you to print count. 30. It's off. Why is it off? Oh, I'm double counting something probably. It was 3 by 3. One, two, three, four, five, 6, 7, 8. That would be a grid perimeter length of 8 for a 3 by 3 grid. And if the grid was 8 high or 8 wide, 1, 2, 3, 4, 5, 6, 7, 8 by 3 high. Eight, be 8, 16, 17, 18. Perimeter would be 18 for something that is 8 by 3. And if something is 8 by 9, it should be 9 plus 9 plus the other dimension minus 2 times 2. It would be 8 minus 2, 6 times 2, 6 plus 6. So, yeah, it should really, the sanity check should be 9 plus 9 plus 6 plus 6 is 30. So that is correct. We are going over the perimeter correctly. Now we can do the label. And this are the points with infinite regions. And we are correctly omitting points D and E. Okay. Use every X, use max min. So this is working correctly. These are the infinite points. And so then the finite points are the finite points would be finite points is equal to points which you could probably make into a set cast hook minus if points and finite points. This logic should be duplicated. That's right. This is wrong. Before is back. So that's right. Those are the infinite points. I'd like to know what are the, and also double check on the count. Okay, that's right. Hey, great. Yeah, I was just printing too tight, I guess. Those are the finite points, the points of finite region. Okay, now finally, for these, we need to figure out which region is the smallest. Or the largest. Which should be a sum count thing over the grid. Basically, for point in, well, for row in grid, for points in row. Find points. I just want to make an association here. A hash. Can I turn this hash into something? Dictionary. I would like a dictionary. So we have a set. A is a set with letter A. set out of a list containing the strings A and B. A. Okay, if I have a set, how do I make a dictionary out of this set? D is equal to dict with A. That work? No. How can I Python dictionary from set with some sort of initial value? Set default. A for A in A. What do you got? You got a list. Can you make a dictionary out of lists? No. Dictionary from list. There we go. Use a dictionary. And then for A in for I in set in A. B sub I is equal to 0. Yes, okay, so we could do it that way. So we have the finite points. I just want a quick and dirty way to just make a dictionary out of them. Just a generic association for point in finite points, insert into this the point, and I guess the area would be 0. And as a sanity check, I just wanted you to print a association. Okay, because we're gonna go ahead and calculate the area now. So for row and grid, for point in row, if point equals in b.keys d point plus equal 1. Right, D. 9 and 17, great. We're in the home stretch now. I want the minimum of these. I want you to print. I think I can do the whole thing in my head. The element. No, I can't. The dot values is a list. The minimum of these. Oh no, the max, right? Maximum of this. And I want you to find right, 17. I want you to find the entry in D that has that value. Do a dictionary comprehension. For item in B. Python find B by value. Assign this into a temporary variable. Or just area is equal to that. Or B value in dictionary. Items. If value equals or just print by 5. Is that right? A, B, C, D, E. E. E is equal to 17. Oh, what's the size of the largest area that isn't infinite? Okay, so I already had that actually. I didn't need the label. I'll just keep that just in case. All right, I think we're ready to find a solution. Largest area. That's the right answer. We did it. We did it. It is late. It's really late. But yeah, Merry Christmas. I was worried that I wasn't gonna be able to do it, but we did it. Advent of Code, day 6. Cheers.